All right, away we go. Like I said, circles easier than parabolas. To have a circle, all you have to know is where's the center and what's the radius. Because a circle has the property that the radius stays the same as you go around. And that's what makes it a circle. If that radius changed, then we'd be talking about an ellipse. So what we want to do is write and graph the equation of a circle, find the center and radius of a circle, and use them to graph the circle. And this is going to be pretty basic compared to what we did with parabolas. I had a lot of questions on the homework. I have to skip this. I would rather not, but I have to skip it because of time. If we have time, we'll come back. But what we need to know is a circle is a set of all points in a plane that are a distance r from a given point. I don't even like that they just do that. I want to say constant distance. That distance stays exactly the same. That's why we get a circle. It's perfectly round. That given point is called the center of the circle. And the distance r, not a shocker there, that is the radius of the circle. Now, because that distance stays constant, the formula that we get for a circle comes directly from the distance formula, which we know as d equals the square root of the difference between the two x coordinates squared plus the difference between the two y coordinates squared. But circles take this formula and make it pretty, which is kind of nice. So the distance formula is where we get the formula for circles. It's just thinking about the fact that, hey, we wouldn't really call it distance here because it's the distance from the center to the circle, and points on that circle to the center is called a radius. So instead of a d, we'd say, well, that's a radius with a circle. And then, the really ugly part of the distance formula is that nasty square root thing all the way across there. So, how do we get rid of square root? Square it. So at this point, we'd say, that's just nasty looking. Let's go ahead and square both sides. It's a good thing those are plastic. That would look like that. And then somebody came along and said, why would we use the subscripts for the x's and the y's when we all know that we're going to want that center for each thing? So why bother with all this x sub 2, x sub 1 business when we can just make it look like this? So that's what they did. That's the equation for a circle. All we need are three things. Three different things than what we needed for parabolas. Three things that are much easier to find than parabolas. We need the center. That's HK. And we need the radius. A lot of times, they're going to give us that. So we'll just plop the numbers in and walk away. And we'll have an equation for a circle. And we'll be done. Let's just say, just thinking out loud here, that you wanted to write an equation for a circle that was centered at the origin, then had a radius of 3. All you would do is look at this formula and say, well, these are going to be zeros. And if the radius is 3, 3 squared is 9. Done. That's it. So the equation for a circle, very basic, very basic. An equation with center 0, 0, and radius r in the coordinate plane will be x squared plus y squared equals r squared. Makes perfect sense. If h and k are both 0, they're just going to drop right up. And we'll just have x squared and y squared. And then whatever our radius is, we'll put it in there and we'll square it. We'll have ourselves a nice little equation for that circle. Down here, they're doing exactly what I did when we went up here. I think I did it in red. Yep, I started in red and just deriving that equation for a circle. So they're just showing how that works using the center. If we didn't have the radius, we could find it. We could use the distance formula to figure out how far it is from the center to a point on the circle, and we can find the radius and use that. Well, there it is. Pretty basic formula. X minus h squared plus y minus k squared equals r squared. We're just going to start using it. It says, what's the equation of a circle with a center at negative 4, 3 and a radius of 4? And right away, I write down my little formula. So what we're going to do, put h and k in and put r in and see what we get. Negative 4 into minus a negative will make that a plus. Y minus 3 squared. And then we do square whatever they use for the radius. So 4 squared is 16. Done. That's the equation for a circle centered at negative 4, 3, radius of 4. What messes with people, if we haven't already studied parabolas, it would be that both of these are negative. We're not used to that. We're used to having a positive value, but we saw with parabolas that our h and our k values both had subtraction in them for conic sections. So this one says an equation of a circle centered at 5, negative 2, and a radius of 8. Help me out. What's going to go in the first set of parentheses? Second set. And what do we put on the other side?
64.
There it is. All right, now, what we're really doing when we have an h and k value is we are translating the center of the circle. So they don't want us to forget that whole h and k business is still a horizontal shift and a vertical shift. So it says, what if we took x squared plus y squared equals 9, and we moved that entire circle 4 to the left and 3 up? Well, we're just moving the center. That's all we're doing. So 4 to the left would be negative 4, and 3 up would be 3. So that would be our new center. Well, it was originally at 0, 0, because there was no h and k, but now there's going to be an h and k. So it'll be x plus 4 squared plus y minus 3 squared equals, and I keep reading, and it doesn't say anything about having a new radius. So we keep the radius. And that means we keep r squared, which is 9. So it says, draw the graph. Yeah, this is the fun part. Making circles is not an easy thing. So we've got a new center at negative 4, 3. And since r squared is 9, that means the radius is 3. So here's what we usually do. Go to the right 3 units, make a dot, go back to the center and go up 3 units. Then go left 3 units from the center and down 3 units, and then just do the best you can. So try and get something rounded off. So you do the best you can. But that's all there really is to circles. I mean, that's how they work. So this says, what would be the new equation for these two with translations here? 2a is going to go left 5 and down 3. So tell me where the new center will be. Now let's get our new formula. So what will go in the first set of parentheses? Second set.
Y plus 3.
Radius. Yeah, it's still 1. They didn't say anything about changing the radius. It just says, hey, here's your new center. B, where's our new center?
2, 3.
2, 3.
Yeah. Yeah.
To the right. Up 3.
Yeah.
X minus h.
X minus 2.
Let's hear it.
Ah.
Second set.
Y minus 3. Oh.
Radius.
9.
No change to the radius. They're just moving the center from 0, 0 to the location. So it is easier just to think, where would the new coordinates be, plop them into the formula, and away you go. So down here, once again, in case we've forgotten, they're telling us x squared plus y squared equals 1 would be centered at 0, 0. In fact, this is called the unit circle because it has a radius of 1. We'll deal with the unit circle a lot next year in pre-calculus. But centered at 0, 0 is x squared plus y squared equals r squared. And like it says, the radius it really plays the role of a, because what it does is it stretches or it shrinks our circle. And we can use h and k to translate. So if you know where that new center is, just use that to translate. Couple of challenge problems in the homework that just ask you to figure out what is the radius. So don't forget, you can always use the distance formula to find your new radius value if they give you the center and a point on the circle. So that's not a big issue. Oh no, huge word problem looking thing. Which equation models our fabulous circular irrigation field?
A.
How do you get A?
Well, because C on it has
Can everybody make out those little numbers in your packet? Some of them are pretty light.
It is
Is it
A.
A?
Yes. A. Video.
So 4 squared is 16. If we squared 100, we're going to have 4 zeros because when you square things with zeros, you just take double whatever the zeros are. So there it is.
A.
It's not a big scary word problem at all.
A.
Thank you, Joe. We got that. Yeah. All right.
Video.
3A says, what is an equation of the circle for a circular irrigation field that has a radius of 12 and a center at 7, -10? Now I'm going to call on people.
Oh. You can call on me.
Because
I
I'm
know these.
hearing from the same
I'm scared.
people every time.
I have no idea what's going on.
Oh, whatever.
Neither do
What
I.
do I do?
All right, Tori, help me out. First set of parentheses. X minus 7 squared. Hannah, second set. Y plus 10. Oh, now for the tough one.
Can I do
Josh,
Ah.
144, 12 squared.
Wait, how'd you guys do that?
Ah.
44.
Jeez, how did you get
So
Quick.
B says, now this is a thinking question here. Will the graph of every equation that has this form always be a circle?
Yeah. Yes. Because math.
Doesn't matter.
The word
Because
doesn't have an
A
H.
to
H.
Then
Math.
0 is a real by itself.
Actually, and I know it seems really like a minor detail, but it's because of the equals.
It's because of the equals.
No matter what,
Got
the radius has to stay the
Good.
same. No matter what, the radius has to stay the same. So for 3B, it really is, it's the distance formula, because these two have to be equal. So this is yes.
It's because of the equals.
If you're walking in, it is. It's because of the equals.
The distance has to be equal. And that's what a circle is. A circle is a center with the same distance every time from the center out to the point side. And that has to do with the distance formula. So the
Same
equal seems pretty minor, but it's huge. Alrighty, you can find the center and the radius of a circle, big shocker, if you are given the equation by kind of working backwards and thinking, what did they put in here to get this? Now, like it says, in some cases we might need to consider the square. We did a little bit of that yesterday for our parabolas. But A is a giveaway. But hang on, I'm going to call on people. I
The
don't wanna-
dead giveaway.
You just have to think about what numbers did they put into this thing. Troy, what did they put in for the center? You sure did. Abby, what did they put in for the radius? They sure did.
A.
So that one was already set up for us. X minus h squared plus y minus k squared equals r squared.
I did not know how to do it.
Here's what we're gonna do.
The eight part.
We're gonna put X's together, Y's together, and then a number that's not helping is gonna go to the other side, and they already did that for us, that's over here. But I need the X squared and the 8X clumped together if I'm gonna complete the square for that. And I need the Y squared minus 10Y clumped together if I'm gonna complete the square. So exactly, this is a double complete
Okay,
the square
wow.
problem.
First one is
Boo.
16.
We don't
How you
want
get it?
that.
About B divided by -2. That one right there.
B divided by 2 squared, so it's 16.
Yes,
Oh.
B over 2
I never do
squared.
that.
16. I knew it. I knew
I'll
it.
be honest, I never do that. I just
Now, if I do this over here, what
you
do I
gotta
have
do
to
it to the other side.
remember? Very important.
This side is 24 now. You gotta do it. And that
Yeah.
one is 25.
It is -10 divided by 2 is -5 squared.
Way back. You gotta add 20 to this side. Next up, 45.
Hey.
We're up to what on the right hand side?
According to my math, it might be wrong.
24 and 25. Excellent number.
Fantastic. It's a 7.
So now, we did all of that completing the square twice so that we could get these written in that X minus H
I
squared
got it.
plus Y minus K squared form. What is it, Justin?
Alright, it is x plus 4 squared plus y minus 5 squared.
So you just remember, hey, what did I square when I was going through this completing the square process? I squared 4,
Well done.
I squared -5. Now
Very
we're
well
not done, but that's huge.
Wait, I would call that done.
Oh, now we know the
Huge.
center.
Yes,
-4,
it's huge.
5. Radius 7.
Now, they don't always work out perfectly with a beautiful R squared over there.
Well, they should.
Sometimes we might get a 59 over here and we have to say,
I
well,
would have
it's a
just
square.
said the radius is 8. I'm one up.
All right. A, again, I'm going
A.
to call on somebody for A.
Yes.
Oops.
You guys just want to speak all
Center.
Okay, Eli, what's the center of A?
-8, -3. Good job. I think the radius is 11.
You weren't supposed to say that. You weren't called on
She
it.
said I could do A.
He's overachieving, that's okay.
She said I could do A.
Hey, you're over.
B is tougher, a little bit.
I'm so glad I did B.
Eli, why are you such an overachiever?
You've been screaming the answers this whole class. What are you talking about?
All right.
Got you there.
So notice I've got my X's lumped together, I've got my Y's lumped together. So what I'm gonna need to know is what number I need in this position. I'm gonna call on somebody, what I need in that position, and obviously whatever I do here, I have to do over here. So, Clarissa, do you have it already? What is it? Oh, no, don't tell me second one, this is the first one.
Yes.
-6 divided by 2 is -3. -3 squared is 9. Now we're going to need another one for y squared plus
I got
14y. No,
I bet it's 64.
That is
The
completely
radius
wrong.
is 8.
see, now he's trying to throw people off here. So, Alyssa, what'd you get? 49. 14 divided by 2 is 7. Square it, and we get 49. All right, on the right-hand side, we have 8 plus 9 plus 45. The not so lovely what?
49. Radius.
Yeah.
Wait.
It's 66.
66.
Do the math.
Told you it was close to 8.
I never did it wrong.
First set of parentheses. Adam, what you got for the first set? Yup. Second set of parentheses. Allie? That it is. So now our job is to tell them where the center is and the not so lovely radius. Let's see. Mandy, what you get for the center? little transposing there for a second. And then the radius. What do we do with it? Well, we're just gonna write the square root of 66. That's what
It's
we're
so
gonna do.
close to A squared.
It
You
is,
put
it
A
is.
in
And in the back of the book, they might put 8.1, blah, 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 you know, but if we're graphing it, we wanna know it's 8.1, blah, 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 but.
We're not
graphing. For that good stuff, then we're okay. Speaking of graphing,
Oh, boo! I hate graphing.
Oh my gosh, are we doing this on the
alrighty, where's the center?
radius of 5?
And then we just give it our best shot, right?
It's square. Use that.
Radius of 5.
We already covered that.
Didn't know.
1, 2, 3, 4, 5. Is this 1, 2, 3, 4, 5?
1, 2, 3, 4, 5. 1,
Oh my goodness. Look at this beauty right here.
4, 5.
Now, honestly, if your circles are really bad, one of the first things you wanna do is make kind of dashed little curves around there, because that'll show you where things are really, really off, and then just go back and make it solid after you know you have things all fixed up.
Look, it's
It looks like a diamond.
Mine looks like, I don't know.
Alright, take a look at this one.
It's very
Center
clean
at?
circle. It's at a 490.
I just connected the dots. I didn't.
Radius of.
Not 7.
Now this one, it would take us a little bit off of our grid. So if it were a test problem, we decide right now that we have to go by twos or something, but this isn't a test problem. So 1, 2, 3, 4, 1, 2, and 7 off. 1, 2, 3, 4.
We get it. You can use anything that's circular.
Use the clock.
And in case you haven't noticed, the bigger they are, the harder it is to get these circles.
The bigger they are, the harder they fall.
It is. It's absolutely true. Again, you can kind of make a little dash first.
Better as it sounds. I'm going to use a carry. The right side of my circle always turns out better than the left side of my circle. Yeah, the right side is just like a straight shot. Oh, mine are that.
Circles. 4, 3, 2, 1, 0. How you feeling about circles?
There.
Circles are much better than parabolas, right?
Yeah, mucho better.
Yeah. Okay, some of you are not feeling real well about your artistic capabilities, but
0. Hey, just connect the dots. You can do
all right.
Alright, let's make a deal. That's a lot of stuff.
Oh,
What?
it takes so long.
Let's make a deal.
No!
That's actually a ton.
That's so much.
It is.
It is.
So why are we doing so many problems that are evens and odds?
Can you take off 7 by 2?
Oh.
For that.
No.
Yes.
Actually, that would be kind of fun.
No!
Oh, well, I can do it then.
Okay, Eli, you can.
You know what? I'd be okay if we get 4 days to do that.
I didn't want you to do too many of any one.
You know what I really
So
hope?
a few of
Since you
these,
put
few
that
of
on
these,
there.
few of these.
Yeah, I hope
that
someone
the
is
people
watching.
that are absent today